Nowadays, all the industries are moving towards cloud and they are building and eventually deploying the applications in the cloud itself. So, in this tutorial, we will understand how to deploy a distributed microservice applications in cloud by using Docker container. So nowadays, this Docker is very famous in the industries. So in this tutorial, we will try to understand what this Docker is and how to deploy it in cloud platform. And then we see the end-to-end product life cycle. So during interview, the interviewer is not just interested in how a candidate know about the development. They are also keen to know how candidate know the infrastructure of the system. So during work, if any issues happen in infra, then he and she can fix that issues. Honestly, nowadays every project dependent on lot of infrastructure tools. So mostly the developer time spent in solving the infra issues only. So let's understand first the what are the cloud terminology used with the help of example. So these are my different microservices. So let's say you have one project and you create these different microservices. And now by using this tool which we call as Junkin, we create a multiple containers. So this D1 is the corresponding container of this microservice. Similarly, these are the different containers of these microservices. So this container allow a developer to package up an application with all the parts it needs. Like for example, let's say libraries or other dependencies. So when we create these containers, it is actually the application that we are building along with all its dependencies and corresponding library we package up together in the form of this, and then we ship it all at a one package. And here we have the Docker. So this Docker is nothing but it's a tool designed to make it easier to create, deploy and run application by using these containers. So please note that this in this particular process we create the Docker images. So how we create the Docker images? So from the application we call the Docker build command, which is nothing but one instruction of this Docker, and this instruction will create a Docker image. And then we call the Docker run command, and that Docker run will start these containers. So Docker build and the Docker run is the most important instructions to start a container of a particular applications. This Docker images can't be changed. Once you made one, you can delete it, but you cannot modify it. So let's say if you need a new version of the snapshot, then you need to create an entirely new image. So that's the only disadvantage in case of Dockerizations. You cannot able to modify the image. Always you have to always entirely create a new image. Now we push this image into a Docker registry. So this Docker registry is the storage and the distributed system for the Docker images. It has the multiple repositories that are organized, and we push our images into this repositories. So this repositories holds all the versions of specific images. In fact, this registry allows the Docker users to pull the image as well as push the image locally. Like let's say if you have created one image from your applications, you can push that image into the Docker registry, and then any other developer can able to pull that image as well from this Docker registry. So let's see from starting to end the complete product lifecycle in the industry. So this is the complete phase of the product lifecycle in most of the industries. So here we are the developers. We develops the different applications, and once we develop that, then we need to commit that into the Git. So Git repository, as most of the people are aware of, this is for committing the changes for all the developments. So most of the industries are using the Git repository only. So here we commit and push our changes, and then we use the Jenkins. So this Jenkins is used to build and test your software project continuously. It make easier for the developer to integrate changes to the project, and it making it easier for the user also to obtain the fresh build. So this Jenkins has a lot of scripts there, and these scripts will take those builds and correspondingly build it, and then it push the image into the Docker registry. And this Docker registry has all the specific versions of all the images. So mostly in the industry, this part, that is the development part of the applications, or you can say multiple microservices, and pushing that changes into the Git repositories is been done by the development team. And then this part, that is writing all the scripts in the Jenkins and correspondingly pushing the changes or pushing the image into the Docker registry, is been taken care by the DevOps team. So most of the industry has these two separate teams are present. Sometimes only one developer will take care of end-to-end life cycle of a product. It means he need to develop it, push the changes into the Git repository, correspondingly write the Jenkins jobs to take those images, like build those images, and then take those images and push into the Docker registry. But mostly there are different teams are there. So DevOps will take care of these stuffs, and development team will take care of these stuffs. And then once we have image into the Docker registry, then let's say you have one QA environment, or you can say a QA team, so they can take that particular build and do any kind of testing. Similarly, same image can be taken by the dev environment as well. Similarly, we can take those images into our staging. So this staging is just the one stage before the production, and this is my final production. So production environment is the one which is actually been handled to the customer. So before any particular changes are pushed into the production, it has to go through this different life cycle. First QA will test, then development will also test separately, and then in the staging branch also they test all the images, all the changes in the images, and corresponding once everything is passed, then we push those changes into the production, that is to the customer environment. Understanding the Docker container and how to build, deploy, and push this Docker images is very important in terms of interview. So as we know, like for every microservice in our project, we had to create a corresponding Docker container. But the question is how this Docker container came into existence. So let's go back to time. So what we have is, firstly we have the same operating system which owns all the hardware resources. So these are my hardware resources like storage device, memory device, or network devices, and these hardware resources is been shared by single operating system. So what they come up is, why can't we do the optimizations and multiple OSs which shares the same hardware resource? So now virtualization came into existence, where you have the different VMs. All these different VMs have the different operating systems, and they shares the same physical resource by using a layer called hypervisor. So this diagram can explain it more clearly. So here we have all the hardware resources, you have the single operating systems, and multiple apps can run on these operating systems. Now here we have different virtual machines. Individual virtual machine have their own guest operating systems, and they shares the same physical hardware resource. Like let's say if this virtual machine required this number of CPUs or this number of RAM or any kind of storage capacity, so we can assign it. So multiple VMs have there, they are trying to share the same physical resources, and then we can run multiple apps on top of this guest operating systems, and these are the virtual machines. This is the physical machine, this is the virtual machines we are creating on top of the physical hardware. So this is called a virtualizations. Now industry do the further optimizations, and the next level is they introduces containers. So basically in this case, in the case of the virtualizations, VMs require the substantial resources overhead, such as memory, disk, or network input output. So because each VMs run in an OS, meaning that VM can be larger and take longer time to create than these small containers. So basically all these different containers shares the same OS kernel. only one instance of OS can run the multiple containers here. So here you have the different OSs, here you have the single OS, on top of that multiple containers can be run. So because this container shares the same OS kernel as the host, containers can be more efficient than these virtual machines, which actually require the separate OS kernels. In fact, these containers also are more portable than the other application hosting technology. In terms of the industry expert, it is possible to support many containers on the same infrastructures. So that's why industry gradually moves from the virtualization to the containers. And this separate containers, we call it Docker container. Because as you see, all these Docker containers share the same OS kernel. And in fact, we use here Kubernetes to manage all these different containers, because in a proper production system can have the hundreds of different containers, or you can say different microservices running as a container. So we use the mostly Kubernetes to manage those containers. Let's see how we create and start containers by using the Docker commands. So of course the first step is we need to install the Docker container in our local systems. So here, for the explanation purpose, I will use the Java Spring Boot applications. So you can consider it as any Spring Boot applications. Please note that application can build in any language. It can be either Python or it can be PHP, it does not really matter. So just for the explanation purpose, I consider a Spring Boot applications. So this is my sample application. You can assume it as a one microservice as well. And using Maven, I build these applications. So it will eventually create a jar file in the target directory. So this is my application.jar file. Now the most important step, that is we need to create a Docker file. Please note that the format of the Docker file will be exactly same, and this is the Docker file. So these syntax that are mostly present in case of Docker file here. So the first step is from. So this specify that which version of JDK supported by the Docker. So we provide the standard version, that is 8. So once we build this Docker file, it download the OpenJDK image of version 8 here. So that's what we specify in the first line. Then second line is add. So here we need to add the jar that our application created into a Docker container. So that's why we specify the jar file path. So this is the path of my jar in my local systems. So mostly jar file created in the target directory itself. So that's how we specify the path. And the next step is we also need to specify the path inside container where we want our jar to be present. So we want the jar, that is our application.jar, should be present in the root directory of the Docker container. We can also specify here /temp/application.jar. Then in that case, our jar will be present inside the container at /temp. Now the next step is expose. So basically we need to expose the container on a particular port, and we consider that port as a 8085 in our case. We can give any particular port number in our local systems. And then this is my entry point. So basically we need to specify the command how Docker will run our jar, because Docker doesn't know anything about like whether it's a Python application or it's a Java applications. So we need to specify the commands through which Docker will run our applications. So that's why we specify here java -jar and the name of our application jar. Once the Docker file is created and that process is done, then we need to deploy our jar into a Docker image and then start that image. So there are two steps. We need to create an image, put our jar into the image, and then we need to start that image. So this docker build command will create an image and deploy our jar inside the image. So if you see in the docker build command, we specify the path of the particular Docker file. as this in this case Docker file is present in the root directory of the project, so that's why we didn't specify anything. So we can put this Docker file anywhere in our systems. So it should be something like this, -f and then our Docker file, and then this is the name of the image. So once we create the image, then what will be the name of that particular image? So in our case we just consider it as a hello world. So once we execute this instruction, then it will create the image and deploy our application.jar in that particular image. We can verify that by using this command docker image. So this will show something like this. This is the name of my image and how much space that particular image has taken, and this is the image ID, that is a Docker container image ID. So once Docker image is created, then our next task is to start our container or start our image. So for that we use the command docker run. So this docker build and docker run is the main instructions of the Docker. So this docker run will specify the port here, and here we have the two ports, 8085 and again 8085. So if you see, mostly this container will run inside a virtual machines. So this 8085 is the port that is exposed for the outer world from my virtual machines, and this 8085 is the port that is exposed from my container. So container is of course running inside a virtual machine, so that's why we specify here two ports. One port is for the container and one port for the virtual machines or any machines, any physical system machine as well. Now we have to give our image name. So the image name is hello world that we have just created. So once we execute this particular instruction, there our container start running. That's it. These are the all process that are involved in case of Docker. It looks pretty simple, right? So now if we want to verify applications, so in the browser we just run localhost, the port that we have exposed it, and then this is the resources. So if you see in our applications here in the request mapping, we are specifying our we are exposing our REST API at /hello/any name. So we just specify here test. So once we execute these instructions, we will get the response as a positive response from the server side. So that's all the process that are involved of deploying the jar or the applications or microservices into a Docker container. And once it's done, then we can push our Docker image into Docker registry. And for that, we just have simple two instructions. We need to tag that particular Docker image with some unique ID, and then just specify the instruction docker push and give the our Docker registry name. So it will push our Docker image into the Docker registry. So any other environment like the QA or the development or staging wants to pull the image, they can easily able to pull by using the docker pull command.